Well, thanks everyone for joining and for your interest in this topic. I'm really glad to see such a representation from so many different consortia. This is great. So let me pop up to the new, does everyone have the new doc for this subtopic? In case you need it, let me know. I can put the link in the chat. Okay. So Tim and I have already introduced ourselves, so why don't our active participants at least introduce themselves. So I'm going to start from the top on my screen. It looks like Satra, you're first.
Sure. So my name is Satra. I'm at MIT right across from Tim at the Broad. I am part of the BICCN consortium. I'm the PI of one of the cellular neurophysiology data archives from NIMH called DANDY. And a big chunk of my group does work on neuroinformatics related to pipelines and workflows, and provenance. So it seems like this was quite relevant.
That's awesome. Great, thank you. Bill?
Bill Shire, I work at University of Pittsburgh. I'm part of the HubMap consortium. I work on the infrastructure component, do a lot of lead software development there. And so we're doing all the software for ingest, which includes running the pipelines and any software QA metrics that anything we can automate QA metrics kinds of things will be included in that. So that's why here I may not be the best fit from everyone in the HubMap team, but you're who you're stuck with at this point.
We're happy to have you.
Helpful. Awesome. Heather, would you like to go next?
Sure. I'm Heather Creasy. I'm from the University of Maryland, Institute for Genome Sciences. We're also part of the BICCN. I'm part of the Neuromolecular Omics Archive, or NEMO. I'm data manager for that. I'm also involved in the NIH Common Fund data. Oh my God, I'm drawing a blank on the acronym now. That's CFDE, Common Fund Data Elements. Yeah, so basically I do a lot with coordinating data and metadata and integrating pipelines and common resources.
Great, thank you. Jeremy.
Hi, I'm Jeremy Miller. I'm a scientist at the Allen Institute for Brain Science. I am a scientist. Primarily, I do my own data analysis and want to know how just general scientists can be produce more reproducible results. But I also have some interaction with the BICCN, and I forgot to write this down here, which I'll do now. But as well as the SpaceTX consortium, sort of through CZI. So hopefully I can bring back whatever we come up with here to I guess, SpaceTX. It looks like we have pretty good BICCN membership.
Excellent, thank you. Matt, would you go next?
Hi, my name is Matt Wyczalkowski. I'm a research faculty at Washington University in St. Louis. I'm involved in the HSAM project, and I do a lot of the data tracking associated with both the specimens and their processing, as well as the data. I'm also involved in the CPTAC3 consortium, which is a cancer proteomics consortium. And there we're responsible for running a suite of genomics analyses, standardized analyses, and so I'm responsible with that.
Awesome. Okay. Would any of our passive listeners want to introduce themselves, or do we want to dive in?
So Kylie, if it's okay with you, since we have two moderators here, of course I'll be here to support, but I think that two moderators might get in the way. So I'm going to drop to scribe, and I'll be here to communicate as well and be a part of the process, of course. Would that work for you?
Yeah, definitely. And speaking of scribes, our next action item is to choose two scribes. So we have Tim, who wants to compete for best scribe with Tim.
It's not a hard competition.
Perhaps one of our passive listeners wants to help scribe.
It's really a generous offer to help do it, because it's the more you've captured, the more we remember what happens in this discussion.
Sure, let me introduce myself. My name is Norbert Tavares. I'm a program manager with CZI for the seed networks. So I'll be scribe number 2.
Awesome. I'll have to keep myself from not scribing. It's like my natural instinct to just type everything people say. That's perfect. Thank you both so much for volunteering for that. Okay. Since we've combined 2 topics here, we have like a plethora of discussion prompts to work through. So why don't we start at the top with the kind of the general of how are you currently sharing your analysis pipelines and protocols? And is it going well?
I'll speak up for HubMap. So we actually aren't really sharing anything publicly yet because we haven't done our first data release yet. But the plan is, so pipelines are all standardized and put into containerized and standard workflow language, CWL workflows.
Mm-hmm.
And we will publish those on Docs Store, and we also have them in GitHub. So pipeline, what was the other part of the question?
Did you feel like
protocols.
That's going well? Oh, and protocols, yeah.
Protocol. I think that piece of it is good. Protocols, we're trying to convince people to document both in Docs Store, which has a, it has a way of of creating documentation for workflows that you pipe for containers and workflows that you add to Docs Store. But we're also trying to get people to use protocols.io to document everything, and we're doing that at the not just the pipeline tools level, but we're doing that for everything from bench, when they're cutting tissue, what are the protocols for that? So we're trying to get everything inside of protocols.io there, and then associate that in the provenance graph with everything. So that's our plan. Having a hard time getting traction on protocols.io at this point, getting people to document stuff there in general, but that's what we're pushing for. So if there's something else that people are using now that is working, I'd love to hear it, because we're still in the implementation phase.
We're in a similar place for BICCN and NEMO. It seems like my opinion or my impression is that the labs are posting their protocols in protocols.io, but all of the informatics and archive documentation is going in GitHub for the most part. We are also currently using GitHub for pipeline code and documentation, but we're moving towards a Dockerized system for a lot of our stuff, or collaborating with Terra and other systems like that.
So we're doing something similar as well. This will be for the CPTAC3 project. This has been going on for over 2 years now, and our pipelines have evolved over time. Early on, it was mostly some of the pipelines were, well, essentially they were all kind of generated in-house. Those were published on GitHub, and they were available on GitHub. I'd say with limited usefulness. Over time, we've been moving towards a containerized CWL model. And I'd say about half of our pipelines right now are in CWL. And so that's been, I think that's been pretty effective. The one thing that we do run into sometimes is that you might have dependencies that are outside of that container. For instance, you have a large database that you need to refer to, and that does introduce some dependencies. We do really try to emphasize documentation and just encourage people to do that. As far as on the more experimental end, this would be for HTAN. We're using Open Specimen as a way of tracking our specimen processing, which is a commercial product, and we're we're using forms and other ways within that to capture some of the experimental details with the hope that we'll be able to then share those more broadly.
Well, I'll speak for the Space TX Consortium, which I think is in less good shape than most of these other ones. We were required to put our protocols in protocols.io as part of the sort of getting the grant. And I think for the experimental methods, that has been working reasonably well. For the computational methods, we're still in the kind of trying to figure out how to do the analysis phase. So the results are kind of all over the place. Some people are using GitHub, some people are using whatever programming languages and sort of scripts that they have in the lab. And I think settling on some place to make things standardize, whatever it is, would be a big advance. But I'd say GitHub is the one that is being used more than anything else at the moment.
So I could speak a little bit, not so much from the profile, from single cell analysis perspective, but some of the things that we've done are Docker containers. Some of the hard difficulties with that is maintaining versions of dependencies all the way down to the operating system level, and making sure that that's a replicable thing over time. And so it's easy to share Docker containers, but creating long-term support for pipelines is a much harder problem, and kind of balancing long-term support with evolution of scientific practices. The other thing that's kind of a question in our head is very often these pipelines are complex, have many paths through them. Whereas due to choices of parameters and other things, people take some paths to it. So the provenance side of this is as equally important as the pipeline itself. So kind of capturing both pieces effectively is a challenge, because while we are using standard ontologies and terminologies for provenance, there isn't a good place for viewing provenance of pipeline outputs, especially for complex pipelines. So I would put that both as challenges that we haven't yet fully solved.
I would agree that their first problem is actually recording sufficient information, and the next is using it for anything, or people finding it or finding it useful. Did anyone?
So
Go ahead.
I haven't introduced myself. My name is Idan, and I'm running the data wrangling and pipeline development teams in the ENCODE Data Coordination Center. So in terms of our pipelines and protocols, we are not switched to protocols.io for the experimental protocols. And in terms of pipelines, we have everything Dockerized, and we are using WDL for our pipelines. All the pipelines are on GitHub, and currently we are using Quay to store the Docker images. And WDL provides what is called metadata JSON that captures all the different steps along the way, so you can go back and track exactly what happened along the line of the pipeline.
Great. So I don't talk too much as moderator. Tim, do you want to introduce what we do for HCA?
Be happy to. So for the HCA, Kylie's team, we do use GitHub. We have a space for people to be able to publicly grab the data. And we do have some documentation in GitHub for developers, focus on developers. And then other documentation sort of like on our project website, the HCA DCP website, focused on users of the pipelines, either biologists understanding the outputs, or sort of a computational biologist wanting a higher level of how to use the pipeline, but not really how it was made, how it was baked. So those are two different places that three different kind of persona get documentation. As far as the pipelines themselves, they are Dockerized. We were using DocStore, and I think now we do a mixture of DocStore and other places too, like Quay. At least we were playing with Quay at one point. If everything
Docker images in key.
DocStore.
Yeah.
I remember at one point we were hitting DocStore and they were getting upset because we were hitting it a lot.
It's Docker Hub.
Docker Hub, sorry. We're using Docker Hub for containers. We use Dockstore in general for pipelines, for pipeline sharing. There you go. And we use Whittle, and we also have, I think there's a really interesting feature for the HCA. Not only do we sort of put the pipelines out in GitHub for developers, but we also put them out in Terra for computational biologists. So if they want to, they can grab the pipelines and they can use Cromwell and other things to execute it in their own infrastructure. But they don't necessarily have to do that. They can actually just use it as is. And that ends up being a nice feature too, so that people can just literally reproduce what we're doing because the pipeline's in a space that's actionable. Or also just grab it and change it and put it back up and do something in a space that can execute it.
Awesome. Thank you, Tim. This was really helpful. So it sounds like, I mean, across a pretty large number of consortia, we are at least using similar practices, but haven't, at least as much to my knowledge, shared that much with each other or sourced others' implementations. How might we help remedy that, and is that a good thing to do?
So there was a question that came up yesterday. I'm going to raise it over here as well. So Docker Hub, Dockstore are great for putting Docker images and sharing things. I think the key difference between Docker Hub and Dockstore is searching for things. Docker Hub is almost useless unless you know what you're looking for. Dockstore has a lot more of the descriptor side of things, and kind of standardizing that into practices across consortia would be a good starting point for being able to. So one of the things is, how do we standardize the description of pipelines? I think just having specifications is insufficient. So CWL and Whittle represent the steps of a pipeline, but that's very different from a biologist wanting to use a pipeline, knowing what it does. So that description level is often missing from some of these things. If you know what pipeline you're looking for, you can find it, but that's a challenge, I think, across consortia in terms of sharing. And then the other pieces come up, which is related to not just how you share it, how do you make sure it's version controlled, and not just version controlled at the level of I have a Docker file on GitHub, but the actual container is well versioned internally. So those, I would say, are two challenges I think that could be addressed not too difficultly across consortia. That's not a huge technical lift, but that could improve cross consortia sharing.
That's a great suggestion. We find that we have a lot of documentation, and it gets really unwieldy to even process it as you're reading all of it, but still better than not having it, which is the case for some of our older legacy pipelines. So it's, do other groups devote time to describing pipelines so they can be shared?
Yeah, so we are investing time in essentially documenting the pipelines on the ENCODE portal. So all our data is ultimately supposed to be processed using those uniform processing pipelines. So for the data itself, like raw data files and processed files, we have visual representation of pipeline steps, so you know how exactly each file was produced. But then each step is linked back to a model that represents the pipeline, including the version, link to GitHub, and specifications, which make sense much more for the biologist and not computational people. So we will explain which assay data should be processed using this pipeline, and then what output type files are produced by the pipeline. So the users will be able to decide if those file formats are useful for them and how to use them depending on the file extensions.
I think sort of a high level question we could ask is, to get people to try and actually use these, is how might we make our sort of protocols and pipelines more simple for the other consortia or for other users? Because that, I think in my experience, if it's easy to use, people are going to use it even if it's not the best way to do it. So if we can make our protocols easier to use, I think people will just naturally come find it. And that also might make it easier for us to kind of use the same thing, whatever one it is. Ideally, if it's the one that's the best, that would be ideal. But even if it's not the best, I think people will tend to use the ones that are kind of easier to figure out.
Yeah, I think this is a
One
really,
thing-
sorry. This is a,
Go ahead,
Jeremy, that's
go ahead.
a really great point. We for a little while, we had this really active project where we were putting together sort of a system where a part of the GA4GH where a pipeline could be submitted to a system, and then that system has different backends on it, and they represent different spaces like AWS and GCP or NFS or LSF, whatever it might be. And then it would run those, or like a DNA Nexus, and it would try to run the pipeline in those spaces and sort of give back a feel for like, could this be used in those areas? And it was really interesting to kind of feedback, like it was just a nascent project, but it was really interesting the kind of feedback we got, because if you're not developing for usability and you end up having problems you don't even know about.
One thing that we run into in terms of documentation, again, a lot of our pipelines are written by graduate students or run by graduate students, and the documentation, it's something that we certainly encourage, but you got to think pretty hard about who the audience is for the documentation. So somebody's a graduate student writing a pipeline, they might have a very different way of describing it than somebody that's a computer science focus. One might be much more of a biological sort of algorithmic description. The other one might be, here's how you run the pipeline. And so that's just something that we come across as we go through and try to QC our documentation, is what exactly are you trying to convey? And sometimes you just have to break it up into multiple pieces like that.
So I think you hit on something there, Matt, that just hit home to me, is you said the word QC. So I think for me, the thing that we probably lack right now is a release procedure that includes QC for these pipelines, at least QC for the documentation. We're doing QA QC to make sure the results are right and all, but we need to include that piece for documentation, say, hey, we can't release this until you give us this, standard documentation, what the stuff that Satra wants.
So since my name, I'm going to put one more thing that I want, which I think is the key to this, which is search. How do I search across pipelines, across consortia, right? So that, again, we'll talk about solutions to this later on, but searching kind of is the key. The things that I want underneath should enable that kind of search.
Who had the repository in the call we were on yesterday, Satra?
Yes. Was
that you that has a repository of, or a standard repository that can be searched?
That's the DocStore one.
Oh, that's DocStore, okay.
Yeah. Which is, I think, out of GA4GH, if I'm not mistaken.
That's what, and we're using that. HubMap is using DocStore as well.
Yeah, and we're using DocStore as well for HCA and for initiative pipelines, and for all the other pipelines that my team develops. Is what we're aiming to do is release them through DocStore. On the documentation side, the DocStore reads the description at the top of a WDL, but that's only a few lines. And so I do have a ticket in their backlog about being able to upload a full markdown that describes the rest of the pipeline with the method on DocStore. So I think that would be really helpful. Okay, so I've thrown a couple of these questions that we've mentioned, the how might we questions up at the top of this section. And quickly, I think we've touched on them a little bit around maintaining repeatable analysis, but if there's any specific how might we questions we might want to tackle in part 2 of the breakout, we have a break at 11, so we can spend a few minutes talking about those. So some of the prompts in this section were around maintaining repeatable analysis over the course of long-running projects, how long we guarantee that an analysis will be reproducible, and how we're tracking analysis provenance, which I think we talked a little bit about that already. I think we kind of framed our discussion prompts as almost like how might we questions, Tim, but does anyone have any thoughts they want to discuss around that topic?
So one question in relation to repeatable analysis is how do we store our Docker containers and layers and modules over time, right? So I think that's a general thing, whether it comes from funding or other things. Docker Hub is great. I can't make any notions that every Docker Hub will stay over a long period of time. So I think in terms of repeatable analysis, getting access to the container images is important. So how do we do that? And then in terms of Docker files and Singularity files, those are both notorious in terms of replicability as generally constructed. So how do we kind of create standards and best practices that ensures that even if you're rebuilding the image, you get to a space of more version controlled such that you can repeat analysis. And then the other related thing with repeated analysis is software evolves. So how do you compare across that evolution of software? So those are 3 things. And then capturing provenance is key. Right now, I don't see a good place where that is captured when people actually run these things. And so is there a standardized way of exposing provenance across consortia of what has been done?
Yeah, I don't know of a standard way across consortia that they're doing it. I think I mentioned yesterday, you might know that. So all of our provenance is we're using the W3C prov standard. So we're keeping everything there, but you know, what elements we're keeping, did have some conversations with someone from HCA to make sure that we're linked up on that. And I think we're pretty close with HCA on what we're collecting for provenance. And so we're storing all of that to the W3C prov spec in a graph database, and we're collecting all that information. We've found that there's a nice, if you use the CWL runner tool, there's a nice option to it that will actually output what it's doing internally in the W3C standard format. So we're sucking all of that in, but you know, the big thing is making, you know, so that's sort of the technical way of doing it, but you still have to make sure that you're collecting good information there, right? I guess that's what this group's about. The QA.
So Bill, we use W3C Prov as well, but I think part of this is I don't see it across consortia. And yeah, if people had to kind of get together and accept that that's a good way of doing it, then maybe we can drill down on properties associated with those entities and activities that would be common across the consortia as a way of, again, creating a search space for what has been done rather than reinventing the wheel in every single consortia.
I agree.
That makes sense. Yeah, I'm not super familiar with the W3C Prov standards, but we have, I think similar to ENCODE, taken steps to version the pipelines as a whole, so including the WDL code and the Docker images, which are also versioned, but giving just like a semantic version at the high level to help represent to the user what kind of, like, what size of change has been made between different versions of pipelines, and also for them to be able to kind of pin to a particular version and say, like, I'm running V1.0 of the pipeline, and then they can kind of clearly understand when something has changed. And that's been helpful because then you can link back to like a GitHub release with changelog information and see the code and see the documentation that corresponds to that version. But it's not super like computer searchable way to understand what a pipeline is doing.
Can I ask, when anyone says we use or we do, you identify which consortia we are?
Sorry, that was for HCA, and we work with a few other consortia. We do that for some of our brain initiative pipelines and are working on doing it for the rest of our pipelines for the production analysis we do at the Broad Institute.
I'm HubMap.
In HCA, we also store provenance information on the analysis in the HCA data store. But like I said, I'm not familiar enough with the standard to know if it's close or complies with that. Okay, so we left off talking about maintaining repeatable analysis over time. I still have a question in the back of my mind about like how long one can realistically expect to repeat an analysis, but we could probably talk about that as we dive into part 2 here. I copied down all of the like how might we and how do we questions that came up in part 1. Tim proposed kind of a target problem for us to talk about in part 2. And so you can see that in the green box under the part 2 breakout if you scroll down in the doc. And I'll just read it out loud. It says, moving towards the FAIR pipeline, because we all love our favorite buzzword. How do we all commit to sharing in a way that is findable and searchable, and what standards around documentation, versioning, and provenance are necessary to make those pipelines usable after they are found? So I know we don't need to solve all the problems in this part 2 breakout, but we can start to brainstorm and also propose next steps.
I was hoping that it was the sort of the voice of that seemed like the voice of what I was hearing in general. But if there's any strong reactions to that, feel free to modify our direction. Just want to keep us focused.
No one's protesting, so.
Can I say one quick thing? So I think this speaks to what Kylee you started with, which is the repeatable analysis over time. I don't think that's quite captured in that target problem. Just that sentiment. I think the rest is good, but the notion that somebody can use this, and that might involve support structures in addition to standards.
Mm. Yeah, definitely. I agree. It doesn't necessarily cover repeatable over time. And I'm certainly curious to chat about that a little bit more if others are interested. We kind of currently just run one version of any pipeline at one time, especially in our like production setup for the Broad Institute. For the HCA and Brain, we've kind of approached it with a bit more of a versioned mindset from the beginning, so we could still run some of the older versions of the pipeline, but I don't know how far back. I don't have like an SLA or anything on how long we could run an analysis for. Has anyone else thought about that?
If you were CERN, you can run up to about 35 years of pipelines.
Wow. Well, that could be our gold standard.
Well, in all honesty, I do want to make sure that we're targeting a small enough problem that we can actually hit it. But that being said, Satra, if you've got friends at CERN, if we end up meeting again with this group and have a solution for findability, then the question about adding that temporal space into it and like how do you keep that thing going? I'd love to be able to hear what CERN's doing. So that could be like a future topic for us.
Absolutely. So I think there are solutions in that space of being able to do it over time. I don't think it's a huge problem for us right now. And part of that is because all our analyses are evolving at a much faster rate. But that might also kind of go back to linking with literature. You publish today, 10 years from now, you want to compare. you want to be able to run something, right? Unless we have captured all the provenance and everything that's relevant to not rerunning it, but you can trust the output that was produced. And I don't think either of those spaces we are at right now. So just the incremental steps of getting fair pipelines is going to be a huge step forward over what we have right now.
So I guess I'm a little curious as to, I want to make sure they understand the problem. Where do the problems come up when trying to run pipelines over time? I mean, I can think of several different things. You know, the operating system might change, the software might change. That might be solved with Dockerized images. The algorithm might develop to the point where things that were used, say, 5 or 10 years ago are no longer sort of considered top of the line. That's a different sort of problem. And then a third problem was, for instance, your reference changes or the ensemble release changes. And so the input, the sort of secondary databases that are input into the pipeline might change. Where exactly does the problem lie? And I think it would be useful to think through the lifetime to kind of separate out these problems.
So I think, Matt, those are excellent questions. I think some of the things that we want to look at are, this goes back to versioning of pipelines. So if we think of what a Docker container does, it's dependent on a few things. Docker itself, right? So you have to be able to run that version of Docker if you want it to be reproducible, or some future version of Docker that supports that older version of the container image. Within the container itself, if you're downloading things, they should be versioned. So some service APIs or other things from which you're pulling data have to exist for you to rerun things. So there are kind of different technological pieces, and none of these are not solvable, but people creating containers have to be aware of this to be able to make sure that even a container today runs tomorrow and can produce the same results. So I think it kind of gets into the reproducibility space, not just the reusability space. And if we as a consortium, again, can come up with, here are the best practices for you to create future containers, these are the things that you have to pay attention to. That would be a good step forward to hand out as a document to developers. I don't think every developer pays attention to all of these components when constructing containers. So those are, I think, some of the things we could tangibly work towards. But it goes back to the pieces that are changing even when we think they aren't.
Yeah, I mean, these are all pain points that we've dealt, or that we're kind of dealing with now as we're sunsetting the Human Microbiome Project. That project is 12 years old, but as part of the CFDE, we're making new resources available and updating data sets. I mean, half the tools that were developed for the HMP don't exist anymore. We have some VMs that we had created, so you can technically still run a lot of those old analyses, but you wouldn't want to. It's no longer, they're no longer appropriate. They've been superseded by better analyses. And so I'm not saying I know the answers, but you know, there's reproducibility and there's reusability. And so you want to make sure that you're not providing something that can reproduce old results just to do it. You want to make sure that you're, you know, providing the best resources.
Yeah, I do kind of think of those as two different issues. I think our older pipelines probably could be rerun with, you know, a certain amount of finding a replacement for something that no longer exists, or like, you know, finagling to make the code actually, you know, run if it doesn't have an inputs, you know, JSON anymore. You could recreate one. Like, there's a lot you could do to run them. But we don't keep any kind of guarantee or any like way to compare that it's producing kind of the same results. Like, we'd have to just compare it to old data and hope for the best. So there's a little less of a way to confirm that something is reproducible.
Just because you can run something doesn't mean you should.
Yeah, that too. And I don't always think of it as something that like we would be rerunning, but more just around, like was pointed out earlier, with publishing scientific papers, like things are supposed to be reproducible to contribute to science. for at least a little while. So that would be nice, I think, even if it was just 1 to 3 years after the pipeline is the paper was published, somebody could use it to further science.
But I mean, I really like the question in here about now I can't find it, but basically like how long should we plan for these pipelines to be, it was worded much better than I'm saying it, but basically how long do we have to plan on, or how long should we plan on keeping these pipelines? Because I mean, 10 years from now, Docker could have been replaced by something completely different. I mean, over the lifetime of the HMP, we saw major changes in technology. Docker was not something that we were using at the start of the pipeline. We were using virtual machines, and even that was fairly new and exciting. So yeah, I mean, what's a reasonable time length?
What do people think?
And I'm not asking for an answer, just like say that's one of the things that I think about.
So maybe the answer is as long as you find the results produced by those pipelines useful. So if you look on, let's say, ChIP-seq analysis that was done 10 years ago, if the results of this analysis are something that you shouldn't use and they're should be deprecated and replaced by something new, then there's no really point in trying to maintain the pipeline that was used 10 years ago.
Yeah, I think that you're, Idan, is that right? I want to make sure I'm saying your name right. Idan, I think you're hitting something that's really important here. Is sort of like, there's also this concept of the value of the data, right? Like, how long would you keep data as well? Like, data that's being generated now is much more valuable than before, but depending upon what we're doing with single-cell genomics, right? And sort of like, to me, it's defining what reproducibility means. So in something that's current and new, a pipeline that's very useful, making it easy as possible to reproduce with containerization and these kinds of things is very important. But for something that's 10 years ago, honestly, I'm not sure that I would want to make a container for it, leave a container out there for that kind of thing, as opposed to documentation on explicitly what the commands were, like the CWO or the WIDL and the parameterization that went into it. So you could technically reproduce that if you really wanted to, because you have the versions of the software and stuff. But more importantly, the value is kind of grokking it, right? And knowing what they did with it, and generally, because you wouldn't use those old software versions to do that, you would actually probably want to translate that forward into something that's more modern, and then look at the analyses if that data is still valuable with more stronger algorithms, right? And so to me, there's sort of like there's a state change where suddenly the data is valuable, but the pipeline may not have been valuable anymore, and so you want to just reproducibility is not actionable anymore. It's more about being able to act on it, to do like lifting it over to a new pipeline if one needed to.
I think there's one more use case in there, though, which is that you're developing a new pipeline and you want to compare the outputs. And so even though you might not use the old pipeline in order to obtain production results, you want to use that to validate your new pipeline.
Sure, yeah, and so if you documented, for instance, if the documentation does include the WIDL, the CWL, the versions of software, the parameterization, you could make that older pipeline and run it for yourself if you needed to, right? If that was that valuable to you to be able to compare the two.
I think, Tim, the challenge might be if you can do that, right? So that's what the problem with the Docker file is, that building the same exact thing gets to be tricky.
No, sure. I mean, even
so if you are
building, yeah. But I wouldn't say I think that's true in general. The standards in Docker files that will allow you to make a Docker container that doesn't move under your feet will also allow you to do the other as well. It's just the availability of the software is the issue at that point, I think.
Yeah. Yeah, even in the last 20 years, I can talk of all kinds of containerization approaches that have come up and gone down over the years, and some of that software would require really a lot of resources to kind of dig up. I was lucky enough to look at an archivist's collection in a library, and I think that's the kind of thing we're talking about. If you look at them, they have things that can read tapes from the 40s and 50s, right? We have to decide, and I think this is what Heather's question is, what is that timeline? We are not archivists, but if we were, we would say all of this has to be maintained in perpetuity. So I think the more practical or realistic timeline, I think, is what we are looking for. And perhaps the utility question that Matt brought up is the one that we live with, which is comparing a current version of something to a previous version of a scientific output. In the context of reproducibility, we kind of use the word generalizability as this thing, that we are kind of interested in scientific claims holding up over time, not the specific outputs. And the question as to how long we can do that and may revisit that claim with newer software and newer data, if that holds up, that's a good place. A colleague of mine uses the term NISDAQ instead of NASDAQ. Each software evaluation on a new data either boosts up a claim or boosts down a claim, and you just track that over time.
I like the concept. I would be weary. So for me, it doesn't speak as much to me that we would need to have the exact software to be able to continue to investigate a real signal in data. Because I think that real signal in data should be there regardless of many kinds of analyses, right?
So that's the intent of NISDAQ, is that data are changing, software are changing, but the claim kind of either gets boosted by that new data and software. So that's not about reproducibility, that's about claim level generalizability.
Right.
And I think as scientists, that's what you want to get at, is that
that's science,
holds over time.
Yeah, it's not, otherwise it's just overfitting. So it sounds like I know I put a target question up there, but it sounds like this dynamic is really ringing to this group. Do we want, or what do we sort of want to focus on here, Kylee? Like, do we want to regenerate the problem statement that we're going to tackle in the next hour, or what are your thoughts as a moderator?
I mean, I'm happy to discuss whatever the group's interested in. I am really enjoying this conversation, so I'd certainly be interested in a problem that we think we can solve by collaborating. And that's kind of the aim of the blue section. So even if we have more than one, I mean, we could meet or invite others that have knowledge on these topics to come up with some standards and some policies even.
Just knowing the last day, I know this thought process has come up in several different groups. So I think post this meeting, one of the things that would be nice is to collapse some of those blue notes into a common area, because I think this has come up in at least 2 other groups that I know of in the blue notes. So there might be a larger group that's willing to come together to tackle this. So that's, I think, a to-do thing just at an overall level. Would love to tackle, again, for this meeting, it might be good to hear from people how they're doing some of these things in their current spaces, how they're tackling some of these problems, and maybe just that idea set is a good kind of starting point.
That sounds great. Excellent. So I know we talked a little bit about provenance mechanisms that people are using already across the different projects, and kind of generally what software we're using and where we're storing things. But outside of that, we talked about, or Tim's prompt at least includes documentation and making things more findable. And then also around pipeline longevity. So has anyone talked to these?
Yeah, if we take the F and A in FAIR, so I think the first question that you have over there, easier to use, how are you making pipelines more accessible? I know Tim talked about Terra, but I'd love to hear about other groups as to how you're making this usable, or is that a small niche of people that you're targeting? Who's your audience when it comes to pipelines? Is it the computational biologist, or is the random biologist able to go there?
I think we tend to gear more towards pipelines for the random biologist. But yeah, they're sort of for, they're on our websites, or they're on the BCDC website. They're for a smaller audience, but yeah, I think we'd love to make them more easily findable.
Well, I'll say a few words about the CPTAC3 project that I'm involved in. It's similar to these lines, not exactly maybe. So again, our goal, the goal of our lab, the sort of thing that I'm quite involved in is running a standard set of pipelines, probably about a dozen, depending on how you count them, for RNA-seq, whole genome, exome, other data types, and then sharing them with the consortium. The focus of the consortium itself is proteomics, but the genomics obviously needs to support that, and so people are interested in having standardized pipelines and standardized results that they can then use in order to advance the proteomics research. This is something that we've been doing for 2 years now, and it is something that's evolving constantly. So this is a resource. One thing that, so I guess there's two parts of that. One is the pipelines that we develop and the pipelines that we run. And as I mentioned, this is something that we're sort of transitioning over to more of these Dockerized and formally defined pipelines, CWO in particular. The other part of that has been actually relatively successful is how we share the data. And that has, again, developed over time. At first, we were just depositing them into essentially an FTP server somewhere, and then we'd send out an email and say, hey, good luck finding it. Over time, we're actually now releasing all of our the data itself still resides on that on this essentially FTP server, but we're developing sort of catalogs of these data, and we're storing them on GitHub. And that ends up being actually a very effective way of sharing this sort of metadata. Essentially, we'll have tables, pipeline version, date, the particular data sets that are being used, including their UUIDs, and then the explicit path on this FTP server. And this is something that's been quite effective because it's this intersection of automatically generated data and then things that you sort of have to correct and fix manually sometimes. And being able to do that on GitHub has been really effective because you can always go back and as you keep notes for every submission, you can find basically debug things, if something breaks. And that's something that's very accessible and people use that all the time. We do that internally for finding, where are the BAMs, and also externally just to share with the entire consortium. So that's something that we've been moving towards, and that's been pretty effective in terms of findability.
I can give some broad strokes about what the Allen Institute is doing, but I'm not involved in the sort of details, so I probably can't comment on that. I know we have kind of ways that I don't understand of making the main website findable through Google. So if people search for the Allen Institute, it pops to the top. And if you search for anything sort of related to, brain maps and that kind of thing, it gets toward the top in Google. And then once people come to the website, the idea is that there should be kind of multiple ways of getting to whatever aspect of it that you're looking for. And then once you get to within that aspect, let's say it's RNA-seq, because that's what I look at. There's, it's a reasonable organization, and kind of the documentation and data related to whatever piece of that you want are going to be both in sort of a general documentation place, and then also the relevant documentation and data will be in whatever subsection you're actually looking at. I mean, I'd say that the general idea is to have a sort of reasonable organization of things, and then within each part of the organization, an easy way of finding whatever you would need related to that. So I know that's really broad, and we've been talking about specifics, but that's kind of the level that I understand. And for for someone who's primarily a consumer, I would say, rather than a producer of this kind of thing, that I find that organization useful.
To speak to the Google thing, does anybody here use schema.org markup for distributing pipelines? So that might be an actionable thing that we could kind of, that would at least allow Google dataset search to kind of search through treating a pipeline as a dataset. I mean, after all, there are digital blobs. They're just digital blobs of different kinds than what we traditionally consider data. But that might be a useful way of just leveraging something that exists right now. It would be, again, a small lift for some people to attach some schema.org markup.
I wonder if like I like that a lot, Satra, but I wonder if there's something more systematic, like lobbying DocStore to allow us to add like that piece of data into DocStore and allow, and like having them require it will make all of DocStore findable.
Right.
And so
yeah, so where we can do it at the kind of infrastructural level, because I think a lot of that data to construct the schema exists in DocStore already. So on one side, they could tell the people pushing to DocStore, you're missing this metadata. And on the other side, they could automatically generate that markup without each individual pipeline developer having to do it. So I think that would be a great way to move that forward. But again, DocStore is just one outlet. Are we kind of going to think about using DocStore as the only outlet for all of these consortia? If not, and I'm a big fan of decentralization in general. So centralized
but
search,
I would like,
but decentralized outlets because they can evolve better.
Yeah, I know. I mean, I appreciate that, but I wonder though if, like, I love the idea of like a federated search for pipelines, but unless that exists, being able to centralize and at least have your pipelines in there as well as wherever you normally have, like and link to your space, which may be a little more tailored to you. I mean, it feels like it's a way forward, right? That like, how else would you make things findable, right?
So what I would suggest is that every consortia, so DocStore, yes, but I think Idan was talking about EU consortia, if that they are distributing things, not necessarily through DocStore. Right? If they had landing pages for their containers that could be indexed by Google, that becomes a starting point. And then somebody could build up a search that's different from Google to do other things. So I think the common ground is the schema. Some of it could be generated automatically from whatever information, and then kind of that could also guide these consortia and places to say, please provide this information if you want this to be more searchable.
That's really interesting. So the schema gets stored on schema.org?
The schema gets stored on the landing page of an item that is searchable by Google, right? So there are a few ways in which you can connect to Google, and that means every item needs to have a landing page. So if you don't provide an API to create a landing page that crawlers can search through, then you won't directly get to that. So it's not a perfect solution because every place is not constructed that way, but it is a kind of simple solution in the short term where people can take care of this at their own site without worrying about a central search because somebody else has already implemented it.
That's really interesting. Any other thoughts on making pipelines more accessible for our A in FAIR?
So it sounds like what from hearing from the group is that most of we're all not all of us, but many of these projects are new in developing pipelines and trying to just get things out and our releases out and stuff, right? It sounds like we've had an adoption of containerization, generally speaking, with this group, and that sort of is the A in this. Like, it's accessible because you could run it in with a container. Is that a general? So if that's the case, are there ways for us to? I'm trying to think about actionable items here to move us forward. If that part is as simple as we're all using containers and the person that we're targeting is in that case, the developer or the very, very CS-oriented computational biologist, then it sounds like maybe one of the things that Satra had mentioned before, as far as maybe as an actionable item around containerization standards becomes important in this space.
I was going to say the same thing. I thought that that seemed like something that we could take a stab at defining pretty quickly, and try it out and see if it helps.
And that might also help towards the accessibility part. So not just that I can run this in a container, because several tools require different kinds of hardware resources to run. And I know different standards kind of capture different elements of this. So if we were to define a container standard that ensures that that information is exposed, then accessibility becomes user. Somebody doesn't download a container that only runs on a GPU that they don't have access to. I'm just giving that as a random example, but I think that's the kind of thing that would improve usability. The other thing I can think of, so one of the projects we run where we're building containers, every workflow also has an associated visual report that's created, not just on things that run, but things that are scientifically interesting for that workflow. And that has had a significant impact on adoption, because everybody wants to look at visualizations of outputs of workflows in a consistent way. So it's almost like a derivative standard that's come out of the container standard. And that might be something to think about, is not just bytes being created, but how those bytes are useful to the scientists. And I know people think about this as separate workflows, perhaps in different cases, but that can also help with the accessibility, that you know what's coming out, not just a provenance graph, which is useful, but most scientists don't care about that level of detail. They kind of care about how is this useful to my work. And so we've kind of taken the approach of provenance is hidden behind, but there is an abstraction of that for the scientists.
This might be implicit in what you're saying already, but like calling out ahead of time what the use cases are of the pipeline and step-by-step instructions for how to run the container. Maybe that's part of the containerization, but some sort of standardized thing where you say, first you download this, then you type, maybe it's just you hit go, but if it's not just you hit go, even if it's you hit go, step 2 hit go, step 3 you're done, but have some step-by-step instructions for how to use it for people who either it could be the level of people who are CS and understand everything, or if the target audience is the general public, it might need to be more detailed.
I think we could certainly iterate on like a template for what's important information to include in those kinds of instructions to help users have a sense of, I guess, familiarity when they get to pipelines of developed by different consortia. They'll say, oh, okay, like I know how to do this because I've done it for this other one.
For some of our users, even just mentioning the word Docker is still a new thing. And I think that's something, again, at a consortial level, we can create a higher level overview of why this is useful. This is repeated several times, but we started using Docker a long time back, and we still have to keep telling people why they should switch to a containerized approach and why that's helpful to them. There is a disconnect between the broad range of biologists and these technologies. And maybe that's something we could kind of say, if you're participating in these consortia, using Docker is a must, and this is why it's useful.
I don't know. So for me, Satra, I'm definitely with you there. But the root for this in a lot of ways is we confound software engineers, computational biologists, and biologists all the time. We have like really brilliant biologists running data centers, and vice versa, really great software engineers we're working with software that's and don't really have the context necessarily. We also have really awesome stuff happening. I'm not saying it's all like that. I'm just saying that we can found these roles. And so I think for me, it's like biologists learning about Docker, is it necessary? Like, I think it's important to define the user persona for documentation and what language speaks to them. So like for a biologist, I don't think I would talk about Dockerization. What I would say is like the pipeline runs in a consistent way and it's versioned, like so they know that it can be done. For a computational biologist, I would talk about Dockerization, and for a software engineer, I certainly would, right? And so, but the instructions on each of those, at least for what we've done, are very different. Like online, we have documentation towards more computational biologists and biologists on that side of things. And it's less about the guts and the glory and more about grokking and understanding what your outputs are going to be and how they were, what was manipulated to get there. While like for the software engineer, like documentation, it's all about the guts and the glory. This is the WDL, these are the containers, this is how you run it, that kind of stuff. And even for like usability for computational biologists, although I'm sure they can run these things, we put it in Terra so that they don't actually have to install it. It's just there and you can run it, right? Pick the version you want and run. And so I think it's like, this is long-winded, I'm sorry, but it's really about, I would be excited about templates for documentation, or at least common elements in documentation we all give, but targeted to users, like for software engineers, and then for computational biologists and biologists or clinicians.
I'm on board with that. I think I was just trying to speak to Jeremy's point a little bit about the use cases. And that's what I think most scientists are kind of interested in. And so to kind of achieve this at the use case, it's not about saying, here's the Docker documentation. It's about saying, here is how you do X with these steps.
Oh yeah, no, I think we're aligned. I was just building off of what you were saying. I think it's great.
I wonder if along the lines of documentation and making the Docker containers accessible to people that are not necessarily expert, if including as a standard, including test data or reference sort of runs that can be done, which would include maybe the visual output as well, just sort of templates for running as a standard, that might be a useful thing, so that somebody can always, when they get a Docker container, they can just do effectively a hello world run on it. That'll just get them started.
I'm loving that. I'm loving that.
So all of our pipelines include section of testing. Every step essentially is tested, and all the testing like reference or inputs and outputs are available on GitHub. And in terms of reproducibility, we make sure that every new change in the pipeline still maintains MD5 identical outputs for inputs, which are identical. And I guess that answers multiple questions in terms of which version of the pipeline now changed because MD5 sum is no longer identical, like files outputs are not identical. It also provides inputs and outputs for anyone that wants to run pipeline for test purposes or for like hello world example. And going back to documentation, I think that we are doing more or less what Tim and others suggested, which is to target different audiences and different ways of documentation. So on the ENCODE portal, there is documentation which is directed on biologists. There is nothing there that will explain which container was used or how to install the container or Docker. And on the GitHub side, there is documentation which is directed more towards computational biologists, which is what should you do in order to be able to run the pipeline. And then in the pipeline itself, there's documentation which is more directed towards engineers.
I'm really loving that. Something that Brian O'Connor, I learned from Brian O'Connor, and I think it might be in DocStore, I'm not sure, but was this concept of the checker step or checker script. Because not everything can be MD5 checksummed or whatever checksummed, because they represent stochasticity in their pipelines, although you try to avoid it. But if you want to use certain things that are awesome, you have to, sometimes it's the nature of the algorithm. And so what his idea was that if it is truly a checksum, that's great. You just have a checksum between like your standard output that you give and the output that they make when they run using your test data, and it says, yes, everything is okay. And then if there's some level of stochasticity, like, oh, okay, I'm using our sim for it, so there's going to be some level of change, but I don't expect things to be more than like one count. Well, then you have a checker script that checks it in that manner, the outputs, so that you can say, oh yeah, it's okay. It's a little different, but we know that that's okay. But you just give them a true false at the end of it, just like you would expect from like a checking with the MD5 checksum or a diff. And that's something that I'm not sure is a standard for everyone. I'm not even sure that I know DocStore supports it, at least, that I would love to see accompanied with like test data, for instance.
So I'm just going to shamelessly beat our group's work a little bit. So we've been developing something called Test Kraken. Besides having a very cool icon that a colleague developed for us, is kind of one that encapsulates these things, which is we want to test containers in different operating system and library dependencies. We want to have a set of tests with input data and output data. And you kind of create essentially a file structure for a container with a YAML spec, and then the library just runs it in a CI environment. Just wanted to put it out there as something that, again, we could kind of converge on the spec side of this, because then that could be implemented by many things in many places.
I would, maybe in a later time, I would love to be able to see, maybe this group, if we meet again, could see like a demo of that, Satra, because it's, I think what's something that we've played with in the HCA that was not successful, unfortunately, at least for now. I think it's visionary and will happen soon. Is this concept of having like pipeline testing. So like an environment where the pipelines are available and the test data is available that we ran, and then people can like modify the pipeline and then run it with the same test data and get a feel for, are you doing better? And just if they're doing better, click submit. We've improved your pipeline, and we look at it and source that in, because we want to use any innovation from the community we can. And it's kind of like something that you would involve like with the Dream Challenge, right? But it's sort of like an always ongoing thing where pipelines and data are available, improve it for us, and we'll credit you. Maybe it's the same spirit of Test Kraken, but I'd love to see it.
Yes, I think there's nothing new in this in terms of conceptual pieces. It's just that we did not find an example of something that addressed all of those components. So we decided to create one. Happy to chat about this in a future time.
I'll second that. I'd like to see it too.
That'd be great. Yeah, we have, like Tim said, our like more thorough like benchmarking service didn't really take off, but the when we do develop pipelines, I think we do something similar to what Edan said. We have a CI hooked up to all of our repos to compare outputs with a gold standard, and at like a kind of a plumbing level, and then at what we call scientific level, just like more full data set. And that helps at least a little bit.
I think that it would be cool. I'm sorry, I'm acting less passive now, but I'm really excited about this conversation. I think it would be like a cool vision. I'm not sure we can do it today, but maybe we could aspire to it, to having something where like we were able to pull in our different pipelines and run them on the same data, for instance, and being able to output and see how they behave, and learn from each other. Because like I know that the pipelines we're writing, we're doing the best we can, but we're not looking at everything. We have so many people, and like Satra, you're doing stuff that we probably wouldn't even think about. But I bet you that if we put our heads together in a technical way, that we could at some point have like a really awesome pipeline that encompasses both perspectives, and then making it so it's user facing and allows, some CS or CB student, and I don't know, anywhere in the world, Australia, Palestine, Africa, wherever it might be, the Midwest, who knows, just to take that pipeline and say, hey, you didn't think about this, and here's an improvement, and boom, like that would be a really cool way of converging in this landscape one day.
Right. And I mentioned this in one of the things yesterday. There are several groups on the planet who are trying to do this. So if we can converge, that would be awesome.
Who are those people? Can you write those down in the document?
Oh, sure. I'm sure you know them. Carol Goebel's group has done a lot of work in the workflow space in Europe. So it started with Taverna in the good old days. She's a big supporter of CWL as a framework, and then more recently Workflows Forever and other things. So again, there's an extended group, and I think everybody runs into these problems, and that's why I think if we can kind of scope out the problem specifically, we will get collaborators and volunteers to kind of tackle pieces. So that might be a good next step for us as a group to kind of say, what are the different subscopes of the problem that we could tackle? But I will put some of the names in the doc.
That'd be awesome. And yeah, why don't we spend some time kind of narrowing down the areas that we specifically want to tackle sooner rather than later, I suppose.
We have 30 minutes to make an amazing blue box.
So I had thrown some of the ideas that were coming up as we talked about them into the blue box, but we can narrow it down or add more at this point. So at one point we had talked about setting some standards around like guidelines for what should be in a container to help make it more reusable and reproducible in the future. So I listed that. Another was around common elements for documentation and instructions on how to use a pipeline aimed at different user personas. And the other around like getting a demo of test Kraken, I kind of just summarized as testing of pipelines, but if there's a better way to frame that one.
I use this term, vibration testing of pipelines.
Vibration testing, fun, okay.
That'd be a little bit too much fun for me. So I'm seeing a lot of really cool things about, I'm not seeing an action item. Think about what we can solve by collaborating. Findability. So I don't see an action item too much about findability. I think that there's been two things. First, I was grokking DocStore, but you're right, Satya, and everyone doesn't use it. But you mentioned a great alternative, which was the schema.org work. So maybe getting the groups to, at least at a low bar, adopting, putting that information maybe in like the GitHubs and stuff like that.
And we can start with DocStore as a community point that implements it so that other people can see. So again, there could be different ways in which we could approach this. But I think
like
that's
both,
a common.
honestly. Yeah, I like both, honestly. Like, I would love to be able to have this group, these consortia at some point accept something to use for just so that people know where to go. But you know what? You're right. We can't, like, at some level, people have to have flexibility. So if someone doesn't want to do that, then at least Google can be this findability. And but if you do put it in DocStore, then other people might specifically go there because, Google, you'll get a lot of stuff.
And the other piece we could do is in that container standardization thing. If as part of it, whatever entry point you run says, here, spit out the JSON LD that corresponds to your description, then it becomes useful for whoever is implementing it or pulling in these pipelines. And it becomes something that's accessible locally if somebody wants to build up a search on top of it.
And a lot of this stuff like this for like these schemas and such and this information, it's the workflow runners already have most of this stuff, I would imagine. So, I mean, something that some of us here could do is, for the CWL community here, advocating in their groups to just have this baked in boilerplate.
So the difference I would make is what Matt pointed out in our earlier discussion, which is the difference between the biological methods versus the steps that are in the workflow.
Right.
It's kind of like making sure that each container, even if it's developed by a CS person, has the component that appeals to use cases for the non-CS person.
No, that's true. That's true. Well, I look forward to maybe later on diving into more detail about that standard and maybe an example of sort of like your vision of how one could leverage it. Yeah. Maybe that would work.
So I've been trying to break these ideas out into like kind of the different parts of the acronym. Did we?
I don't think we had all talked about interoperability.
I didn't think so.
Yeah.
All the topics are so intertwined. I was trying to think through it. I don't think we really did. Yeah.
Are there thoughts from the group?
data set standards that a container works with? So if we are going to focus on pipelines, the interoperability part might come from describing what sorts of data standards you're willing to work with.
Are you saying, Satra, that maybe interoperability is about having standard data sets that are used for benchmarking and things like that?
And so when it's related to the accessibility piece, when somebody wants to run a container, they either have to format data into something that runs that container. So that's where I think there's this impedance matching between the data standards and the container standards. So if a container says, I work this way, then perhaps that makes it easier and for people to work on different data sets that have been conformed to a similar standard. So that's the interoperability piece, but also helps with accessibility piece.
Yeah, so we did this, we did some work for something we call the methods registry, which is a way of like putting different analyses just online for people to just find ability for some tooling that was compatible with the DCP data. So like, if you got the data, what can you do with it? Well, you can use these tools. They are compliant, or at least, you know, they'll read it in. And one thing that was really, I think, that we learned very quickly is, number one, it's complicated. And number two, like, as far as interfaces go, you really have to document how to perform a use case. So I want to do this thing with the tool or that thing with the tool. You sort of have to have like the parameterization, because a lot of tools have a lot of parameterization, and that's for flexibility of the computational biologist, which is great. But when you're trying to describe what I did or how to do a certain thing, the flexibility is not actually helpful. What you want to know is like explicitly, like these are the parameters you would use to do it. And so that is, and to me, is an interface, thinking like command line.
Yeah.
And it becomes really important to document like that. So yeah, it rings true to me.
So most students, postdocs, and other scientists I've interacted with, they all create Swiss Army knives. They can do all kinds of things because that's the easiest way to hack their system. They're not software engineers.
Well, it's a flexibility thing too, right? Like, as a data scientist, I want to be able to do these several things to be creative and explore, and then I will harden myself down to a subset of this functionality whenever I know the data.
Yeah, I've never seen that really happen, that latter part. It happens in certain places, but in general, it kind of becomes this wonderful Swiss Army knife or a Frankensteinian monster, but
it's science.
Yeah.
What are some other thoughts in the group?
I struggle with not talking too much as moderator, but I, on the interfaces front, was going to just mention that there was another subgroup that was focused on data format standards for these consortia. And so thinking of kind of the input side of the interface to the pipeline, like we could at least try to stay in touch with what they're thinking about. And even if it's not helpful to the entire world of people analyzing data, we can at least try to move forward on choosing some standards for these assays, and hopefully can help influence other pipelines that we develop too. Although I'm sure data formats will continue to change all the time.
I think that maybe one of the biggest things that we could do as a group here is just a general agreement to adopt data standards, whether they're G4GH or from that group or whatever, just to make sure that, like some of the work that we did with the BICCN was literally like taking a pipeline that existed because it's excellent and changing their bespoke outputs to like VCF file. I mean, it's not a great format per se, but there's a lot of tooling around it, and it really opened up stuff for people, right? And we don't even have a real standard for like expression matrices and such on our space. I know imaging is like, they have some standardized, like some big projects for standardization, but there is some variability there too. So one thing is just for us to adopt standards as opposed to creating new ones.
Oh yeah, no, let's not create. But yeah, that's a good point, Tim. That is the majority of the work that we've done for some of our pipelines, is just to take something that was developed in the lab and make it comply with more standard like open source packages and also data formats. Has anyone else run into that kind of work as well, or do you all start with the standard formats from the beginning?
So I will say for the SpaceTX consortium, that was the primary driver of the whole thing, is to take all of these crazy outputs that come from different people doing relatively similar experiments, and have the output be a standardized format so that anyone doing a downstream analysis could just take that format and not have to worry about exactly what the sort of all the starting stuff was. Even that took more than a year or two and was really challenging. But if we assumed that the standard format was there, then it did make kind of this aspect of it significantly easier. So I think that may, all of that part may have fallen in the other subgroup you were talking about, but there's no question that having that standard format was key for sort of doing what we wanted to do.
That makes sense. Any other thoughts on interoperability areas that we could tackle? If not, I know we talked a lot about reproducibility and reusability. I don't remember which one the R is officially, but I put both for us at least. And I put the frameworks for testing of pipelines and kind of discussing standards around that in this section. What else do we want to add here?
I almost wonder if the containerization standards goes here for reproducibility and reusability, as opposed to accessibility. Not to be like a stickler.
No,
I guess I am. Sorry.
Probably helps with both.
Are there other low-hanging fruit that we think we can do this year to, like, these things can be done this year? It's exciting. Like, are there other things that we can do this year with the people that are in this call to improve reusability or reproducibility?
I guess around containerization, I don't think it's under containerization standards, but you know, how we store, we had a discussion about how they're stored and how they're stored long-term. You know, do you just store the Docker file? Probably not. Do you store the image? Do you keep it on, you know, is it on, you know, doc store long-term, you know?
I think within that containerization standard, an hour or two of discussion with the right people, I think one can easily come up with the best practices. This is not a long thing. And so
Right.
even within the year space, this is a short thing that one could kind of get a draft out of.
Yeah, even just getting people to be aware of like Docker file best standards is like, gets you at 80%, I think.
Absolutely.
I agree. And I know we talked about it a little bit. It'd be really interesting to me to take a stab at writing, like, I always forget whether it's SLA or SLO, but like that kind of document around reproducibility and reusability. Even just to say like what we're aiming for in the short term, even if it's a low bar.
Yeah, no, I think that's great. We will need focus, and that'll help focus us. I'm going to just go out on a limb here, and there's a lot of things to do here, so I presume we'll be meeting again. Hopefully that's part of this. What I would love to see potentially is having sort of like a website, but maybe a GitHub is easy enough for us with a wiki or something that goes through and collects this stuff. Like these are the standards that we came up with. These are the agreements that we have as a group that we're doing. Any example data can be put in the code side of things. An example schema.org use, for instance, an example Docker file, an example SLO associated with the SLAs, whatever it might be. Just having that somewhere and having it in a place that's maybe not. I'm thinking about an idea of maybe putting that like in the what's it called, Kylee? The general GitHub like space for like all the
Data biosphere.
The data biosphere space. So it ends up not being branded to any of us, but just a common space. What are thoughts about this very specific thing?
I don't know what data biosphere is, but I'll look it up right now, but I'm up for a common space.
The data biosphere is kind of a loose agreement around doing open source data processing, developing software that can communicate via interfaces, and just generally moving in like that kind of direction towards software. If you go to databiosphere.org, it links you to a blog post that discusses it. And then there's a GitHub org that has a selection of code that tries to adhere to this.
Looks good to me. I'm just browsing it right now, and
It's a really loose
yeah.
thing, but it's kind of formed as like a common Switzerland kind of space for any of this.
I think about it as like the hope is like having a space for us to make modular components of the infrastructures we need to make that work together so that people can plug and play and use things as needed. And so standards interfaces come up a lot now.
Around reproducibility and reusability, my team has been working through some automation to release our pipelines with versions and changelogs and kind of curating a release package or what's it called, assets on GitHub. When you have a release, you can have assets with it. So for us specifically, we run into issues with like workflows having sub-workflows and tasks and everything needing to be packaged together for it to actually be useful to somebody, because we store multiple pipelines in one repository. And it's kind of just in its first pass of automation, but it's been useful for the team so far. And if people were interested in that idea, I'd be really happy to try to make it something other people can use in the future, and I'd be happy to show it.
That would be useful to my group, definitely.
Awesome. You can have that as an action item as well. I'm sure it's probably really specific to our repo to start out, but it's something I would really love for others to be able to leverage, because I think having a semantic version for a pipeline is something useful to us and to users. Satra, I see you've shared another link.
Yeah, I think there's a lot of overlap across different things that people are doing. So if we can kind of converge on some of these principles and apply those same principles across different projects, I think that would be a great place for us to reach to. So we've been developing knife flows for the exact same thing. These are modular workflows or nested workflows or other things that could be installed, run, tested as modular units, or imported in the case of Python workflows. Again, the word knife flow comes out because we do neuroimaging, but the concepts are way more general than neuroimaging.
Cool, yeah, it'd be really interesting to hear more about that as well. Yeah, you're right. I think a lot of this, I'm sure much beyond our group, there's just a lot of overlap. Like our meeting, the people on this call, there's a lot of overlap with these same problems. And so it just hearing about the things that are out there is really, really useful. Okay, I guess we kind of put the recommendations for what we want to do inside of the bullet points under each letter. So I'm going to just maybe combine those sections. And of course, Kaiser might get mad at us if we do that, because you guys have like a whole template, huh? Will it be okay?
The template is there to guide you.
Okay.
You can do what you need to do to articulate your science, your scientific thinking. While I'm on the mic, I'll just remind you there's some information in the chat, the Zoom chat, about what to do after lunch, which is in about 10 minutes or so.
Great, thank you.
Good, thanks for your good work this morning.
So if you're interested in discussing these topics further, I see people already kind of throwing their names and emails and which consortia they work with in the blue box, which is great. I'm really excited to continue talking about all of this. And does anyone have any thoughts on, I don't know if it's appropriate to put to volunteer other people's names in here, but there's a section on additional expertise we might need. Do you know any ideas on particular areas or groups we might want to get in contact with?
I really feel like some of this stuff, if we're going to be thinking about how to like have standards, reference data sets and maybe like ways of converging on testing and things like that, I've always like wanted to be able to bring Dream Challenge into that. I think they're a really cool group and they were interested. So maybe we could reach out to them.
Tim, by that, did you mean Gustavo specifically? Did you mean the IBM Dream Challenge thing? Or is this some other Dream Challenge?
I'm talking about Dream Challenge as far as like the computational biology challenges that we do, like best fusion aligners, those kinds of things that we'll do. It's actual organization. But I can like, yeah, sure, yeah.
Yeah, I put in the chat window the one I know of when I hear the word Dream Challenge.
Gotcha.
That's a great idea, Tim. Maybe when we have the conversation about testing, we could pull them in. We might want to include somebody from DocStore if we're going to talk about the schema.org and like DocStore integration idea. We work with that team a lot, so we can definitely include them. They might be interested in other aspects of this too, but at least the findability one sounds especially relevant. Did we miss, I know the list of consortia at this conference is like 20 different ones. So are there any in particular that we want to try to find a contact from that we don't have represented?
Yeah, I think that IHEC consortia would be good.
Sorry, can you say the name of it again?
IHEC, IHEC.
Thank you. Awesome. And I mean, feel free if you are on this call representing your consortia, but you don't feel like you're the best person to represent them during future conversations, feel free when we kind of send an email afterwards to pull in the right person.
So Satra mentioned earlier too, I don't know if we listed here or not, but there were two groups that he and I were both involved in yesterday that some of this stuff crosses over with that we could.
Do you remember what the subtopics were called?
Let me go look it up. Because that was yesterday, I don't know.
I think data architecture was one.
There's data storage and data movement underneath data architecture. We were talking about pipelines and such, and we were actually decided to try to come up with a common pipeline that would be shared to do specific things, a thing or things, which we could do that in fitting inside the standards that we're doing here, maybe. And then in the afternoon, it was not finding it in the list on the website. Let me.
I was on the subtopic of data architecture yesterday about interchanging data and metadata between consortia. And that was talking a lot about data formats, both for metadata and for data. So if there's any kind of conclusion that comes out of that group, that would be useful. And oh, that also there's a good point that I think either this afternoon or currently right now, there's a subtopic about, or there's a breakout about FAIR in general that I'm sure has a bunch of different subtopics. So that will overlap with that a lot too.
So the other
Yeah,
one,
I'll actually be leading one of
but
those.
it's
Sorry?
The other one from yesterday afternoon that Satra and I were both on was profiling analysis, how to make your containers fair. And that was, it was a small group, but we had a good discussion.
yeah, that's really a cool topic. I love these ideas of like, a lot of times when people think about FAIR, they think of data, which is just super important, but like FAIR analyses, FAIR containers, these are essential as well. And it's good to see them coming up.
Love
Yeah,
FAIR.
there will be a talk this afternoon. I'll be participating. I'll be co-moderating a FAIR discussion.
Oh, great. Okay. I look forward to joining that then. The maybe our virtual board will help us merge those. Great. Do we, so I can take the action item of kind of reaching out to everyone after all of the dust is settled from this virtual conference and trying to set up a meeting maybe in a few weeks to a month from now. Does that sound okay with everyone?
Yeah.
That was good.
Yeah, I think that maybe, we'll talk about the cadence when we get to that meeting, but that sounds like a good starting.
Yeah, I don't think I'm the right person for this from SpaceDX, but I'll try and find someone who I think would be a better fit for this group.
Yeah, it'd be great to have a representative from the imaging side or spatial side.
Bug Ambrose and make him find someone, or we'll reach out to him and get him.
This is great. I always feel like I have such a niche set of interests in the scientific space around pipelines and pipeline development. So it's really fun to talk to others that have a similar interest and have even more experience than I do with it. So I'm really looking forward to meeting with everyone again and discussing more of these topics. Most people aren't that excited about them, so it's great. We have just a couple of minutes until lunch, so any last thoughts?
Nice job, Kylie. Thank you for walking us through this discussion.
Thank you.
Thanks. Yes, thank you everybody for joining. I really appreciate it, and for your participation and your note taking.
Great job.
Nice to meet you all.
Yep, you too.